My name's Magnay. I'm a CTO at Hentsū, and we consult, deploy and manage public cloud for our customers. We specialize in the asset management hedge fund space. So think like high availability, high security, regulatory compliance. We're based in London and New York, and I've just come off a big multi-region Azure deployment. Used Terraform to manage Azure infrastructure. I thought I'd come and tell you how it went, and kind of share bits of what I've learned of using Terraform on Azure, which this was my first time using Azure compared to previously as AWS. So Azure, we've got our virtual data centers worldwide. So we can use Azure instead of building our own data centers. We've got regions all over the world, so suddenly we've got global reach. We can position infrastructure where our staff are or where our customers are, and it's all linked together by Microsoft's super fast backbone WAN. And then you fill your data centers, your virtual data centers, your public cloud VNets with whatever you like. And then if we blow up the world, or I don't know, news these days. So in Europe, we get Ireland, London, Cardiff, Frankfurt, Netherlands. There's 2 more coming in France because pourquoi pas? And then Terraform is really good for configuring the software-defined networking that we need to build out inside of our virtual data centers. So our network ranges, our subnets, our routing tables, and then dropping virtual machines onto all of that, and also dropping platform services too. And if you then blend it with other public cloud platforms, because Terraform will work across, it's got this plug-in architecture, it'll talk to different clouds, you get even more reach. But this one's a snapshot from 2016, and Azure's got nearly twice the number of data centers in 2016 compared to Amazon. So Azure seems to be better at positioning data centers closer to areas of population, closer to your offices. So I'm going to talk about Terraform, which is a product by a company called Hashicorp, to show how we can move away from using the point-and-click GUI to the portal to manage Azure, and I'll explain how it's a bit different from using PowerShell and how it complements the two. And this infrastructure as code style of where we're taking what developers are getting good at using source control to version their stuff. We can bring some of that to version what our data centers look like. But this infrastructure code, you can't really, you can't just drop operators into developer ways of thinking. It's a bit of a cultural shift, requires sensitivity. So I'm not going to just show you loads of code, except for I am, because it is a lot of code, and we've got to get used to programming our way through deploying Azure resources. If we get rid of that. So it's a way to manage Azure. They're calling it a domain-specific language, which is developer talk for a language you can just use for one thing. It's not like PowerShell, which is you could do a plug into .dot. You can do anything in PowerShell, but this language is just for deploying, running your infrastructure. It's easy to read. I find it easier to read than ARM templates in JSON and CloudFormation templates also in JSON. You can comment it, which you can't do with JSON. So you can make it easy for you to read, and you can make it easy for the rest of your team. You can hand it over to someone else. They can read it too. It's quite easy to write. And it's driving the Azure API. So it's not doing anything you couldn't do with PowerShell or through the portal. They're all different tools that are driving Azure, Microsoft's APIs to make changes in Azure. This is just another way into it. And you don't have to deal with the API yourself. Terraform will do that on your behalf. Works on Windows and Linux because we've got everything. We've got to we've got to deal with these Mac users. We've got to be sensitive to the needs of our developers who love their Linux. But also we want to push these workloads off onto maybe a scheduler or some other back-end system to do our work for us, and that might be running Linux. So Terraform will work across all platforms, and it makes it super straightforward. So it'll go across your organization very easily. It's declarative. So you describe your Azure environment, how it should look, but you don't really care how it's going to get there. So it's like desired state configuration. And then Terraform will do this diffing exercise to look at your environment, compare it to the code, work out what's different, and then come up with a plan of changes. So in PowerShell, you've got to work out the order that you're going to do things. You've got to say, okay, before I can create a subnet, I've got to make a VNet. Before I can deploy a VM, I've got to create this NIC. Terraform, you don't really have to worry about that because Terraform works out all the dependencies for you. And if you write some code to deploy a VM, say, if you ran it a second time, it will fail because the VM already exists, all that kind of stuff. So Terraform takes that complexity away of having to understand the state of things. It will deal with that for you. So this is an example. Here we've got two resources. We're saying we're going to have a resource group, which is Azure's amazing way of just bundling up stuff. Like VMware, you have folders, and you can then permission off what's in the resource group and decide who has access to make changes to it or not. And in this resource group, we're going to create another resource called a virtual network, a VNet, and give it a name called network, which is a stupid name. We're going to give this resource in Terraform a name in the Azure portal called production network, giving it an address space and a network range, which is going to help Azure route data to it between VNets and between on-prem and your VNets.
How do you find what's new and what's being renamed or modified?
I'll show you. So this is, and we're going to put it in West US, and resource group name, and we're starting to already use variables. We can cross-reference things. So this resource group, this VNet, is referencing the name of the resource up there. So you can avoid repeating yourself and trying to keep everything all in sync. Once you start using variables and these cross-references, it suddenly makes life a lot easier as you want to start pushing changes through. And inside the VNet, we're just making one subnet called subnet 1. So that's the sort of boilerplate example on the Terraform website. And we'll go through a couple of these and we'll actually run it live so you can see what's happening. So that gets you a bit of presence in sunny California that you can start dropping your VMs on. And there's not much to it. There's loads of stuff on this slide, but the idea is that Terraform is kind of plugin based. So it's got a plugin for Azure, and Hashicorp and Microsoft together are working on these providers to manage, to keep Terraform up to date with resources and services in Azure. So you can start managing all of this stuff through Terraform. Even anything that you can't do in Terraform, you can drop back into ARM templates. So that is your catch-all until Terraform can support it natively. The Terraform way of working. So you start off, you write a bit of code. Start small, like that first example to spin up a VNet in California. You run terraform.exe in plan mode. And what it does is it looks at your code, compares it to Azure, works out what's different, and it will build an execution plan of what it's going to do. And it'll put it on the screen. It's like a what if from PowerShell. It'll put it on the screen to tell you what's going to happen if you ran this. And it'll tell you four things. One is your code wrong. It's just going to break and crash. It'll give you green lines to say resources that are going to be added. It's going to give you yellow lines to say resources are going to be changed. And then red lines is resources that it's going to destroy because you've decided in your code you don't need 8 VMs, you only need 3, whatever. And then, at the time you're choosing, you hit Terraform deploy, and it'll then take that execution plan, fire off hundreds of API calls to make it happen. And VMs, network security groups, penguins, fallout. You don't just do this once, though. And it turns into a circular workflow. So you edit some code, you do a plan, work out if that's what you want to do, hit deploy, make the changes, and then you can go back to edit the code. And just iterate as you get new requirements, you want to make changes. Environments you don't need anymore, you can get rid of. You need new environments. Just keep editing the code, running through plan, running through deploy over and over again. And your data center becomes much less static than it used to be compared to, I'm going to have to buy a rack and a top of rack switch and a new core because that core is now full and all that stuff. It just becomes so fluid. And then at the end of your planning and deploying, you can hit destroy, it's tracking all the resources that it's creating and managing. And when you decided you don't need this environment anymore and you don't want to pay for it anymore, you hit the destroy button and it cleans up for you, which is often a big hassle as you get. If you start creating things manually in the GUI, tearing them down again is a bit of it can be grief. So the strangely severed hand means it's demo time. And unlike Mark, I'm going all in for live. So this could go any way. Let's see. Right, so we've got a bit of code. We're going to make a resource group. And inside the resource group, where are we putting it? We're putting it in UK South for London. We're going to create a VNet. In the VNet, we're going to create some subnets. Subnets 1, 2, and 3. We're kind of doing this pattern a lot. We make one that's sort of shared services where we can put Active Directory, file servers, development tools, Bitbucket, that sort of thing that everyone needs to get to. And then we put all the other sort of application environments on their own subnet so we can compartmentalize things and permission things off with security groups. We'll make a public IP so that we can have an IP address on the public internet, which compared to talking to internet service providers for this kind of thing is just light and day. Azure will just give you public IPs anytime. And then we'll make a security group, which is like a firewall rule, and you wrap your network interfaces or whole subnets with security groups so you can really control where everything's going. And we'll make a rule in our security group of an inbound rule and drop in a virtual machine with a disk. And yeah, so I'll show you the workflow, which is a sort of a what if step first. So Terraform plan. So Terraform is going to look in the current folder, find the code, and decide. So in the current folder, it finds the code, compares that to what's in the environment, and decides it needs to do lots of greens, lots of creating stuff, It's going to add 11 things. And if I can get here, I'm making a resource group. I think it's called demo or something. Nothing exists yet. That looks pretty much what I expect to happen. I can hit apply. Create. So in the background, Terraform builds this graph. It's nice. Stuff is appearing already. So Terraform builds a graph of all the things that you want to deploy and works out how they're related to each other and their dependencies. And it will automatically spin things up in the right order. And it will parallelize as well. So it knows it has to create the subnet first, so it'll create the subnet, but then VMs, it can deploy the VMs in parallel, which is quite tricky to do with iterative PowerShell. So you don't have to really worry too much about the order that you put your code in, and if things exist already, it'll just skip them and carry on from where it left off. So I'll leave that going. Spinning up a VM, it will take, I think, something like 3 minutes. So I've got a larger environment here, which has got lots of stuff in it, and it's got, what's it called? I want the security groups, there we go. FortiGate, right, so we've got using FortiGate firewalls, and Azure will do virtual versions of FortiGate. So say I've got my inbound security rules, and this is a nightmare. So there's always some guy, Dangerous Dave, who I'm just troubleshooting. So I'm going to go in, I'm going to add a temporary security rule. Crazy Dave, temp. It's always called temp, isn't it? And I'm going to allow SSH from anywhere on the internet to some box. Then we go back to the resource group of everything. Right. How are you going to find what changed? What did Crazy Dave do before he went 5 at 8 o'clock, last minute check-in, I'm going on holiday? You've got no chance. But now we've got this amazing diffing engine. I've got my security groups that are described in here, and they're all kind of nicely commented, so I've got half a chance of keeping track of everything. But if I do get Terraform to do a compare, Terraform plan. So if I compared the current state to what's now live, what's going to change? It says one thing needs to change. This is a bit hairy, but I'll see if I can find it in this mess. Anyone? There we go. So I've got this firewall rule called Crazy Dave temp, port 22, and it's going to go from something to nothing. And I can do Terraform apply, and I'm now going to revert Crazy Dave's. It's not troubleshooting, it's more trouble blasting, making more problems than he's actually fixing. And yeah, and we're back to normal. If I do a plan now, it should just go, yeah, everything's fine. The state of our environment matches our code. No changes required. One more thing we can do is we can share this way of working with developers. So one thing what I've done in the last deployment was we made 2 resource groups, one for ops, production IT, and ops are taking care of the virtual networks, subnets, routing tables, firewall rules, site-to-site VPNs, all that stuff the developers don't really care about. Developers just want to be able to spin up the VMs. And So we create a second resource group for developers, permission that so they can make changes to it without being full-blown subscription contributors, God access. And then we give them their own Terraform. And this one, I like IntelliJ where I can shrink things up and make it a bit cleaner. So I just give them a mini Terraform with, they can manage the security rules for their app, which gets them, hopefully they can start thinking about what ports need to be open, what ports don't, without having to talk to production IT and get them involved in changing firewalls. They can run the firewall rules for their app themselves and version the firewall rules for their app with their app in their source control in their code repository. And this is going to spin up a VM, one VM, which is Ubuntu, a second VM, which is going to be Windows Server, and a third VM, which is going to be, doesn't actually say, but this is going to be a Windows workstation. And a lot of the complexity about building VMs and making decisions about disk sizes and storage groups and container in a storage group and all that kind of stuff. I can hide all that away in a module, which is kind of like a function in PowerShell world. So I can make a module called Windows Server, and then they can go off and fire off as many instances of Windows Server, and all they just need to do is change these parameters. So they just pick a different host name. They get to choose where they're going to put it, which they need to choose at least which subnet to put it on. So Ops have prepared in their Terraform a subnet for developers to use and put some guardrail security group around that whole stuff. But then VMs can just mess around with the size of their VM. They can choose different image versions. They can choose different editions of operating systems from the marketplace. And also we can tag stuff as well. And we've made tag a mandatory variable. If they don't tag it, it doesn't work. And when they've tagged it, we can find all their stuff, and we can shut it down out of hours, and we can bill them for it. We can also you can gamify it as well. So you can work out, based on the tags, whose environment is the most expensive, and try and get the developers to start competing to who can make their stuff the most lean and efficient. So let's try fire that off. So Terraform plan. So this would be a developer running this who hasn't got full-blown Azure access, and he doesn't necessarily need to know too much about the complexity of virtual networking. He just needs to be able to copy and paste, basically, and then he'll get his environment. Apply, and he can kick this off in the morning after he's had a coffee and his stand-ups. And then at the end of the day, or at the end of a test, after an experiment, instead of spending loads of time cleaning up and undoing the effects of releasing software onto this box, he can just bin it. He can just hit Terraform deploy, undoes everything, hit apply again, get a fresh environment, without hassling the operations guys. Say, you know, you just gave me that VM. I've broken it. Can you give me another one? We can hand this over to them, and then operations aren't becoming a bottleneck for the developers. And 3 minutes or so later, this one's quite nice. It's kicked off multiple VMs at once because the VMs aren't independent. So in total, it takes as long as the slowest to spin up box, which is the Windows 10 virtual desktop. In our first test, in our demo, we should now have bunch of stuff. Demo. Yeah, I've got a virtual machine there now up and running. And if this is coming off my budget, so I'm going to Terraform, not that one, is it? Yeah. Terraform. It does give me a "Are you sure?" And it's listed in red what's going to change. It's going to clean up the stuff I just provisioned and stop charging me. So it's quite effective. Let's get out of this VM. So it kind of worked. That was nice. So Terraform's good for your operations because you can deploy, change, version your whole virtual data center in code. You can check it into source control. If things go wrong, you can just check out the previous version and revert back. We saw how it makes that plan. You can give that plan to someone else to run for you out of hours, which means more time for us chilling out and less pointing and clicking really late on the weekends. It's good for security. Security guys like it because they can enforce configuration. So for example, you could just run plan continuously, like every half an hour or something. And if something has been changed that's not been put into code and gone through the right sort of release process and sign-offs and all that kind of if Crazy Dave goes in and makes a quick test, that's going to light up when we hit Terraform plan. We can then alert on that. We could even automatically revert. If you use Git with the software and the source code version control system, when you commit changes into Git and you say, my code is the best, I'm uploading it, you can put a comment in there, which becomes a history of all the changes that happen to the code. So at the end of the week, when you want to push a big change, well, the aggregation of all the changes to the data center, your virtual data center, you can look at your commit history, and that will become almost like a release notes of here's all the things that's going to happen. And you can see who in the IT team committed all those changes. So you get who changed what and why, which is very useful. You can delegate access to Azure or permissions to make changes to a scheduler like Jenkins or TeamCity. So Git commits trigger checkouts and Terraform runs, which means you don't have to give everyone lots of privileged access to Azure. You can just give the change control system effectively. Security concerns. It's got these long-lived API access keys. So Terraform being an application, it can't pop up a prompt saying, type in your ID and password, do your MFA. It uses client ID, client secret, which is kind of like an ID and password combination. And this is typically really long-lived. Yeah, it's long-lived. So the default when you create a key pair in Azure app registrations is 1 year. So you've got this superpower ID and password that's going to linger for a year, and it's so tempting to just copy and paste that into the Terraform code, into scripts, check it into Git. It goes everywhere. So you need to get everyone in the habit of not storing keys, these credentials in code or in source control. And these tools like Terraform don't put these keys in their config files because malware is looking for these files now and will steal your keys and then spin up botnets on your account. Even storing these keys in environment variables is not great because environment variable is effectively plain text. If it's a machine environment variable, anything on your machine, anyone else who logs onto your machine can see it. If it's a user environment variable, anything you run can see it. That amazing thing you clicked on that came in via email. So if you're going to use keys, use short expiry times. It needs effort at the moment. It's not straightforward. You've got to write some code to generate yourself a new token, set it to have a 1 hour expiry, and then you're off to the races. So go for short expiry times on these highly privileged plain text stored credentials, just to avoid a denial of service, or even worse, denial of wallet, because it will cost you a fortune. So it's good for developers. We can manage ops world, where we do kind of the shell of the data center, the virtual networks, the routing tables, the subnets. And then we can have, within that, developers can spin up their own ICE environments. And it's still within our control. We can still ring fence their subnets with sensible firewall rules about this environment can't get to production, but this environment can, that kind of thing. But we can like delegate the boring maintenance of spinning up and tearing down development environments to developers. And if they're production environment, if they're used to managing their own like lab environments, getting them to manage the production environment for their app, why not? Copy and paste almost what they used to spin up their lab, paste that into what's being used to spin up new versions of the production app. And to developers, once they check out the code, they just CD into the folder that's got the Terraform code, hit Terraform apply. They do that in the morning. And at the end of the day, Terraform destroy, they stop paying, and they get a fresh environment each morning. So why start looking at Terraform now? Because it's been a while. It's been around for a while, but the difference now is there's some love going on between Microsoft and Hashicorp, who are the vendor that makes this tool. I think Microsoft have got this new, much more open source friendly, and they're looking at what's happening outside of the Microsoft campus, and they can see this Hashicorp suite has got momentum. This is some director of program management saying that we're excited Hashicorp tools now fully support managing Azure. So before it was very much an Amazon focused product and a Google, but the support for Azure a year ago, it was not good. And I was trying to use it, and it was, you'd hit a brick wall pretty quickly and have to resort to bits of PowerShell here, bits of Terraform there, but now it's good. I think as Microsoft are releasing new platform services or new features, they're working with Terraform to get the provider support up to make it really useful for everyone to use really quickly. Terraform videos are appearing on Channel 9. So Microsoft's embracing what? The new shiny. Oh my goodness. Now, infrastructure code needs this shift into this idea of continuous integration. The developers have had this for a while now, and it's partly why they're getting really fast and releasing stuff really quickly, is because they can start parallelizing. Continuous integration means they sort of work on their own bits and then merge all their own bits and work together really often to come up with an end of sprint release, rather than before one person would do their work and then the next guy would do the next bit. They can now parallelize, and it's through these tools like Git. So if you're a non-developer, consider the octopus. This is our app. Client requirements said 8 legs, must swim fast, whatever. To get new requirements, it needs, one requirement is we need hard glasses, and another requirement is we need a cowboy hat. So if this was our Terraform, this is a state of our data center when we deployed it, and that's on the master branch of the code. That's fine. Someone else can start working on the next environment on another branch of the code, and someone else can work on another environment or new features, new file rules, whatever. And then eventually, we need to then pull all the changes together into a new release on the master branch. So these tools are really good at merging different copies of the same code together again. And now we have a new release of our code, a new version of our data center with some extra subnets, with some extra VMs. And that master branch then gets picked up by Terraform, pushed into, applied to live, and then off it goes. And so as developers are getting faster, ops need to change the way they work to avoid becoming a bottleneck and slowing down the developers where we used to do a release once every few months. Now they want to do daily changes to the data center. And then ops can also benefit from the same ways of working, some of the same tools. From my experience using Terraform in a few deployments now, and the latest one on Azure, I would definitely say, compared to like an ARM template, we have to describe the universe and deploy it. Terraform starts small. Just start with the core services, and then get that out, and then build and build and build in lots of small changes. Don't mix manual deploy and Terraform. So you either do Terraform or don't. It's quite difficult to have one guy in the ops team using Terraform to manage stuff, and then Crazy Dave is doing it all manually in the portal still, because Terraform won't know about the resources, and it's possible, but it's complicated to take stuff that's been deployed manually and retrofit it into the code so that it doesn't get binned and destroyed next time someone does a Terraform push. I don't want to talk about it, but remote state is something you need to look at if you're going to start looking at Terraform, and it's basically where Terraform tracks what it's deployed and how it thinks things are set up. Don't have that on one guy's PC. Push it into Azure storage, and then everyone's code can refer to that remote state. Also, the developers, with their versions of their Terraform code to manage their environments, can reference it to get the names of things. Ops need to learn source control. This not to be underestimated. Git is a bit of a strange concept to get your head around if you're used to just putting the code on a file server and calling it v.1, v.2. There's nothing wrong with that, but to do the merging of code and the check-ins and the commits and the history, we've got to move on to version control systems like Git or Bitbucket. Establish a resource naming convention quickly. That's like any data center build you do. Decide on the naming convention up front. Don't change it as you're going along, because that causes chaos. Avoid these long-lived API access keys. You've got to give credentials to Terraform. Just try and do it safely. I've got some code to create new creds I can show you later if you want to. And there's a vibrant Hashicorp meetup in London. It's always oversubscribed, so if you want to go on, you have to get on it as soon as the invite comes out. And there's a Terraform book. I'd bring it along, but it's an e-book, so I can't. But it's not expensive, and you can download it and Kindle it. Okay, that's me done. Any questions, or see you at the pub?
Does it handle any kind of in virtual machine state at all?
Yes, good point. So It's not Puppet, it's not DSC. It doesn't really care about what's happening inside the VMs. So it complements other config management tools for operating systems. It's there to deal with the surrounding infrastructure. And you can do your first bootstrap scripts. So the VM, when it starts, installs Puppet or DSC or that kind of thing.
So it handles the VM extension as well, does it?
Yes, VM extension is okay, but it's not config management for the operating system level.
Has to do with importing like XMLs and stuff like that into security groups.
You describe the security groups in Hashicorp's language. I can show you over here, but it doesn't.
You import from XMLs and stuff like that.
So there's no kind of looping capability, anything like that?
I haven't done. It's not like a programming language. There is a count thing, so you can say I want X of this.
Thinking I've got a list of a CSV of 100 NSG rules.
Yeah.
And writing them all out manually.
Oh God, yeah.
Half a day.
So if you want to import something, copy an existing environment, then it can consume JSON. So if you can take your PowerShell, convert to JSON, get it in Hashicorp expected format for JSON, that might be a way to transfer data in. But I've just been building from scratch on like greenfield or physical data center to cloud migrations. Okay.